Hello and welcome to Miss Ma's Advanced Functions class. This is 1.1 Functions. Okay, we're going to start with a game, and all you gotta do is get a piece of paper and write the numbers 1 to 12, and then we're going to write yes or no next to those. I'm actually not going to tell you the question. You're just going to have to try to figure it out on your own. So just, try and write them out. You're on your side of the video, and I'm on my side of the video, and I have no idea what you're writing. So you can get it wrong. That's okay. And you can change your answers as we go along. So hopefully you'll be thinking about it, having a little critical thought. What are the characteristics that make a yes or a no as we go along? Okay, so hopefully you've written down 1 to 12, and we're going to start numbering these off. So the first one right here, it's a graph. This is 1. This is a set of ordered pairs, 2. This one is 3. It's called a mapping diagram. Mapping diagram right here. Number 4, a heart. Here's number 5. It's a happy face because we all love math so much. Number 6, y equals 1 over x. Number 7, a cube. Number 8, a number 5. Number 9 is x squared plus y squared equals 32. Number 10 is another mapping diagram. Number 11, another set of ordered pairs. And number 12, another graph. Okay, so go ahead and write yes or no next to all of those, and again, you can change your answer if you want as we go along. I'm going to start telling you what the answers are, and again, you can just change your mind if you want. That's okay. Okay, so here we've got a graph of a parabola, and the answer is yes. Number 2 is also a yes. Number 3 is a yes. Number 4, no. So you might want to pause the video right now and just think about what characteristics make all of these similar or dissimilar, and go back over 5, 6, and 7, change your mind. That's okay. I can't tell. Alright, number 5, no. Number 6, yes it is. Number 7, nope. Number 8, no. Number 9, nope. Number 10, also a no. Number 11, nope. And number 12, yes, it is. Okay, so you might want to pause the video right now and write down, what do you think this question is that we've been asking? What makes a yes or a no? So go ahead and do that. Okay, hopefully you paused it and you wrote down, is it a function? The big hint is the title, 1.1, functions. So the question was, is it a function? Well, what is the definition of a function? Let's look at it. Actually, first, before we talk about functions, we've got to talk about what a relation is. A relation is a relationship between two variables, usually the x and the y, the independent and the dependent. So a function is a type of relation. It's a special type of relation where every x value has only one y value, as in there are no repeating x values. You could have repeating y values, but you can't have repeating x values. So that's how we would figure it out. So let's go back and look at some of these, and you can see that the yeses will not have repeating x values. So with this graph, you can actually use the test for graphs for functions, which is called the vertical line test. So basically, if you draw a vertical line anywhere on the graph, it's going to touch only one time. It could touch 0 times, but it can't touch 2, 3, 4, 5, 6 times, or any other number of times. It's only going to touch one time. Then it passes the vertical line test. If it touches more than that, it fails, and it is not a function. Number 2 is a set of ordered pairs, so you can see that it's x, y, x, y, x, y, x, y. So we're only going to look at the x values. We don't care about the y values, because we only care about repeating x values. So here we've got the 1, a 3, a 2, and a -1. There's no repeating, so it is a function. Number 3 is a mapping diagram. It's just another way of showing a relation. Actually, we could write it like an ordered pair, a set of ordered pairs. In this case, we've got 3 goes to -2, 4, -2, 7, 5, and 8, 1. You can see that the x values do not repeat, and also when you draw the diagram, it only has one arrow coming from each x value, so that means that it is a function. Number 4, if we again use the vertical line test, you can see that, it fails. 5, happy as it may be, fails. Failure. 6, y equals 1 over x. You might remember it looks like this, or maybe you never learned it, but you can see that from the graph, it does not fail. It actually is a function, and it is one of the parent functions we'll be talking about in 1.3. Number 7 is a cube. It's actually in 3D. It's not a 2-variable relationship. It's a 3-variable relationship, so it's not even a relation, and therefore is not a function. 5 is one-dimensional, so it's not a function either, and not a relation. X squared plus y squared equals 32. This is a little review of the circle, so x squared plus y squared equals r squared. A circle is not a function. Number 10, we've got the 7 going to 2 places, the -2 and the 5, so it's not a function. 11 goes, the 3 has 2 different places that goes, so we've got 3, 1, and 3, 8, so that doesn't work. But number 12, it's just a regular line, so it is a function. Okay, so let's talk about the domain and range. Domain and range are possible for both relations and functions. You can find them for either one. Domain is the set of all possible x values, and range is the set of all possible y values. So we'll do some examples here. Here's that parabola again. You can see that as we go to the left and to the right, there are no restrictions on domain. That's what you should think about when you think about domain and range. Do I have any restrictions? And I don't. X is in R, and that's it. So no restrictions there. Range, we only can go up to 5, so it's y in R. Y is in the real numbers such that, that's what that line means, y is less than or equal to 5. And that's the domain and range. Okay, for the set of ordered pairs, it's not going to be the real numbers because it's not continuous. We're only using the numbers that we see, so we're just going to make a list of all those numbers. And we want to make that list in order, so let's do it from lowest to highest. So we'll go -1, 1, 2, 3. That's the domain in order. And the range, so we were only looking at the x values there, and the range is going to be all the y values. And because I have a repeating 2, I don't have to write that 2 times. I'm only going to write it the 1 time. So the range is 2, 4, 5. Okay. For the mapping diagram, the domain is right here and the range is here. The domain is where you start and the range is your destination. So you just have to copy them in, make sure they're in order. 3, 4, 7, 8, and the range -2, 1, and 5. Y equals 1 over x. You could do this from the graph, but actually you can do this algebraically as well. You just have to think about the restrictions on whatever it is, in this case 1 over x. So thinking about the x, we know that pretty much anything you put in the bottom of a fraction will be okay. The only thing that you can't do is put 1 over 0, because 1 over 0 is bad, oh bad. So it becomes undefined, so we don't want to do that. So we know that the domain is x in R such that x is not equal to 0. And that's the only restriction on it. The range, however, is something we have to think about sort of separately. You have to think about all the results of 1 over x. So if you think about the results of 1 over x, like you could get, you know, if I put 1 over 1/2, this is 2. Okay? And if you don't remember how to do fractions, you can go and review that on your own. But if you do, then you will see that I am right. So basically you can go really, really, really high with the y values, and you can go really, really, really small. But the only thing that you can't do is you can't get 0. Like y cannot be 0. Why? Because, well, if you wanted y to be 0, you'd need 0 over something, right? And we'll never have a 0 in the top. It's a 1, and it's set as a 1, so y cannot be 0 is the only restriction that we have, and that is the domain, or sorry, the range. Okay. Okay. So x squared plus y squared equals 32. That means that the radius here is root 32 because x squared plus y squared equals root 32, and we're centered at 0, 0. So it looks something like this, and you're going to have to pretend that this is an actual circle that is centered. And so this is negative root 32 over here and root 32 up here, and then root 32 up here and negative root 32 here. So you can see it's all of the values, anything in between, so it must be, it's continuous. X in R such that negative root 32 is less than equal to x is less than equal to root 32, and the range is y in R such that negative root 32 is less than equal to y is less than equal to root 32. You'd only have a list if it was not continuous. So when you graph this kind of thing, it's going to actually only have points. Don't connect the dots because you're not in kindergarten anymore. Negative 1, 4 is here, 3, 1 is somewhere like here, and 3, 8 somewhere like up there, something like that. So you're not supposed to connect the dots. This graph is exactly representing this. You can see it's not continuous. None of these are touching. If you make them touch, then you did it wrong. So when you do your domain, you should have a list, and that list is just going to consist of these two things, negative 1, 3. Again, don't repeat, and range is, I should use my squiggly line. Range negative 1, oh man, range is 1, 4, and 8. Don't worry, I only have 2 left. Okay, so again, this is a mapping diagram, and you don't have to write 7 twice, you're just going to write it the one time, 3, 4, 7 in order, and range negative 2, 1, 5. And here we have our line, and just a reminder for the line, there are no restrictions, so x in R, y in R, unless of course you have a vertical or a horizontal line, then it's a little bit different. Okay, so we just talked about what a function is, we talked about the vertical line test and no repeating x values, and then we talked about how to find domain and range. Thanks for watching, and I will see you in class.